Hello everyone and welcome to our presentation. Imagine a city where vehicles aren't just moving, they are communicating, making real-time routing decisions and avoiding congestion intelligently. This is not science fiction. It's the future of transportation. Today, we will be presenting a research paper that explores this vision. SeScR, SDN-Enabled, Spectral, clustering-based optimized routing using deep learning in VANET environment. This paper proposes a hybrid model using clustering, machine learning, and SDN to improve vehicular communication. So, we are group number 64. I am Navoda KDL under registration number 4088. And we are excited to take you through this work. So let's move to our next slide. This is the content that we are going to cover in this presentation. So let's move to our first topic, that is our overview of this paper. So this paper was authored by Ankur Nahar from IIT Jodhpur and Debashish Das from IIHMR, University, India. It was presented at the IEEE 19th International Symposium on Networking, Network Computing and Applications in November 2020. As of now, the paper has been cited 13 times and recognized for its contribution to vehicular networking, deep learning, and SDN-based routing. So let's move to introduction. To set the stage, let's understand what this paper is all about. VANETs, or vehicular ad hoc networks, allow vehicles to communicate wirelessly but suffer from issues like rapidly changing topology and unreliable routing. To resolve this, the paper introduces SeScR and SDN-Enabled protocol that uses spectral clustering to form stable vehicle groups and deep reinforcement learning model to optimize routing decisions. All decisions are managed centrally through the SDN controller for improved adaptability and efficiency. So let's move to the next slide. Let's now look at the key problem that motivates this research. Existing routing protocol in VANET struggle with fast-changing traffic, limited adaptability, and poor quality of service. SeScR address these challenges by combining spectral clustering with deep learning for smarter real-time route optimization. This hybrid approach enables more stable communication, reduced delays, and better overall network performance in dynamic environment. So over to you, Vidhusankar.
Thank you, Latin. Uh, let's look at the contribution of the paper. The paper makes several noteworthy contributions. It introduced the SeScR protocol, integrating SDN, spectral clustering, and DDPG. It offers a graph-based clustering method for grouping vehicles dynamically. And also it employs DDPG to learn routing decisions in continuous environment. Finally, it reports measurable improvements in delay, throughput, and processing overhead compared to the S16 protocols. Okay, let's look at system architecture overview. So the vehicles are occupied with onboard units, also known as OBUs, and transmit data. Roadside units, also known as RSUs, receive this data and forward that data into the centralized SDN controller. This controller analyzes the network and makes routing decisions. Its communication is handled via the you can see IEEE 80.11p standard desi for vehicular networks. Okay, let's we can look at the spectral clustering methodology. Uh, this protocol we are talking use this spectral clustering to create groups of nearby vehicles. Here, each vehicle is treated as a node in the graph. Then edges are weighted based on the distance and speed. The system calculates an affinity matrix using Gaussian kernel, and also the cluster heads are selected based on the metrics like relative velocity and not connectivity, ensuring the long-lived and stable clusters.
Thank you, Isankar. This slide shows deep reinforcement learning how applied. DDPG is model-free continuous control RL algorithm. This algorithm uses actor-critic architecture. Actor select routing action, critic evaluate action based on reward. When considering the state, vehicle position, speed, orientation, action, direction of packet forwarding, learns optimal path using experience, replay, and target network. Let's move to the next slide. This is the algorithm flow, SeScR protocol. There are two phases. First is clustering, second is routing. When considering the cluster phase, vehicles create weighted graph, affinity matrix, and Laplacian calculate. Spectral clustering perform. Cluster head select via eligibility score. Second phase, in routing considering, SDN controller use DDPG to evaluate paths. Actor select action. Critic evaluate. Experience stored in replay buffer. Optimal path learned over time. Now, when considering the next slide, this is the experimental step. Mainly use of Omnet, and Sumo. Scenario 10,000 meter multiplied by 10,000 meter area. Vehicle density 25 to 200 vehicles. Speed range 0 to 108 km per hour. Transmission range 100 meter to 300 meter. MAC protocols IEEE 802.11p wave. Simulation duration 600 seconds. I hand over to this presentation to the continuer input. Thank you.
Thank you, Vishal. Let's discuss about the performance metrics of this routing mechanism. Compared with protocols like MFCAR and TDDRL, it achieved 10 to 15% lower transmission delay, 18 to 22% higher throughput, and approximately 10% lower computation delay. These gains are largely due to the use of deep learning for adaptive routing and SDN's centralized control capability. Let's move to the next slide. To conclude, SeScR provides a powerful solution to routing problems in VANETs by combining clustering and deep learning. The use of spectral clustering ensures long-lived, reliable clusters. DDPG enables real-time context-aware routing in continuous environments. The system consistently outperforms several existing methods across both clustering and routing benchmarks. Let's move to the next slide. In the future, the authors suggest incorporating factors like driver behavior and road conditions to make the model even more realistic. They also propose extending the work to real-world deployments, moving beyond simulations to field tests and real-time evaluations. And that's the end of our presentation. Thank you very much for your attention. We hope this presentation gave you a clear understanding of the SeScR protocol and its contributions. Thank you.